This is Dr. P. Jaikanth Yadav. I am working as an assistant professor in Institute of Aeronautical Engineering College. My course title is Complex Analysis and Special Functions, and today my topic is the continuation of Milne-Thomson Method. For Milne-Thomson Method, I want to discuss case 3, and we have case 4 also. In the previous lecture, I have discussed when the function f of z, analytic function, and it is given that real part is given, and we are directly constructing f of z. That is in case 1. And case 2, imaginary part of the analytic function is given. Without evaluating its real part, directly we constructed f of z. That is case 2. Now, today I am going to discuss case 3. This is the difference of real and imaginary part is given. Okay, so here u is the real part of the analytic function, and v is the imaginary part of the same analytic function. So here it is, suppose u minus v is given. In that case, how we can find f of z? So that is interested here, and that is the interesting point here. So for that, what we will do, we will take f of z, whose real part is u and imaginary part is v. So for this, we are giving it is equation number 1, and what we will do, we are going to multiply equation 1 with I. So you will have this term I times u and minus v. So now in the next step, what we will do, we will add equation 1 and 2. So you will get 1 plus I times f of z. In the right hand side, you will get u minus v, which is the real part of 1 plus I times of f of z, and imaginary part is u plus v. Okay, so I am writing this expression. As this form: capital F of z is equals to capital U plus IV. Okay, here I am taking as f of z as 1 plus I times f of z. Okay, I am writing this equation into this form. Here, capital F of z is 1 plus I times f of z. Right, so I am making it is equation number 3. So it is given to us u minus v. What is u minus v? U minus v I am taking as capital U. Okay, and v taken as capital V. Okay, right. Yes, capital V is taken. Capital V is u plus v, and capital U is u minus v. So here we are constructing f of z. Here capital U and v is defined like this. So in this case, what is given? U minus v is given. That means for capital F of z, its real part is given. Capital E is given. Now, it is easy for us to construct capital F of z with the help of capital U by using Milne-Thomson method. Right. Now, to apply Milne-Thomson method, the function capital F of z must be analytic. So, first of all, you have to decide whether it is analytic or not. See, capital F of z is defined as small f of z into some complex number. Constant multiple of an analytic function is also analytic. Hence, capital F of z is analytic. Okay? Right. Now I have capital F of Z is analytic, and I also know its real part. Now I can construct capital F of Z with the help of Milne-Thomson method. After finding capital F of Z, my interest is not with the capital F of Z. My interest is to calculate small f of Z. Small f of Z we can calculate with the help of the formula. See here, from equation 3, I can write small f of Z as capital F of Z by 1 plus I. This is the procedure. We can find small f of Z if u minus v is given, means the difference of real and imaginary part. Next one is case 4. In case 4, it is given that u plus v is given. The same procedure I am applying here also. Okay. In that case, equation 1 is defined like this, equation 2 I times f of Z, and you will have like this. And we will add the both equations 1 and 2. We will have this expression. Same procedure. Here capital U and here capital U is u minus small u minus v, and capital V is u capital U small u plus v. Okay, and you know from equation 3 f of Z is defined as 1 plus I times f of Z, and f of Z is analytic, we know, and the multiple of constant multiple of f of Z is also analytic. Hence I say that capital F of Z is analytic. And I also know its a real part. Capital F of Z real part is u, and imaginary part is capital V. What is imaginary part? Capital V is small u plus v. So in this case, what is given? Small u plus v is given. Right. So here I am going to assume that I know capital F of Z, and I also know its imaginary part. Now with the help of Milne-Thomson method, so in case 2 we discussed already. What we discussed, f of Z, whose imaginary part is we know. Then we can directly write the analytic function in terms of Z. Similarly, we will use the same procedure. Capital F of Z also we can construct, because here we know it's the imaginary part V. Okay, then we can directly write small f of Z is equals to capital F of Z by 1 plus I. With this formula, we can find small f of Z if u plus v is given. Now I will discuss an example. You can understand more. Right. Here, find the analytic function f of Z, which is defined as u plus iv, such that u plus v is x cube plus 3x square y minus 3xy square minus y square plus 4x plus 5. Okay. So here what is given? Sum of real part and imaginary part is given, and our interest is we have to construct f of Z. What is f of Z? And also it is given that f at 0 is 2 plus I, 2 plus 3i. Okay. Now, how to write solution? Here, given f of Z, which is u plus iv, right? Then what I know? Then I can write I times f of Z is I times u minus v. So if I take it is equation number 1, and if it is equation number 2, then adding equation 1 and 2, we get 1 plus I times small f of z, which is what? I'm just adding these two. Here I can get its real part will be u minus v and the imaginary part will be u plus v. Okay. This expression I am writing into this form, or capital F of z is equals to capital U plus I times v. This is I am taking as equation number 3. Okay. So here I am writing the above equation into this form. Then I have to define, I have to mention what is f of z, because I am using capital F, where capital F of z is taken as 1 plus I times small f of z. Okay, this I am going to take equation number 4. Okay, and what is capital U? Capital U is small u minus v, comma capital V is small u plus v. Okay, right. So we know capital F of z is analytic, and also given that what is given to us, given that in this problem small u plus v is given. Small u plus v means what? Small u plus v is capital V. Capital V, which is u plus v. What is the expression? Expression is x cube plus 3x square y minus 3x y square minus y square plus 4x plus 5. Okay, this one is given. So we know I am writing the same expression with the symbols. V is a function of x comma y. Okay, so that is writing in terms of xy. I am mentioning these symbols only. X cube plus 3x square y minus 3x y square minus y square plus 4x plus 5. Okay, so now I have to calculate what is the capital V sub x. V sub x means partial derivative of v with respect to x. So this will also come in terms of xy, because I am doing partial derivative with respect to x. So I will have 3x square plus 6xy minus 3y square plus 4. This is v sub x. Similarly, I have to calculate capital V sub y, and capital V sub y is, so this one, this is v. Okay, now I am going to calculate partial derivative of v with respect to y. So I will have 3x square minus 6xy plus 2y. Okay, this is also function of xy. V sub y of xy. I will write somewhat clearly. Capital V xy. Right, this one. Now by Milne-Thomson method, we have here, I know it's imaginary part, when I know imaginary part, I can construct capital F of Z. I'm constructing capital F of Z, not small f of Z. Okay. So capital F of Z is integral capital V sub y. Here x replaced by Z. Okay. And y replaced by 0 dz plus I times integral v sub x. In v sub x, we have to replace x by z, y replaced by 0 dz. This is arbitrary complex constant c. So I'm going to write integral. Here we already calculated v sub y. In that x replaced by z and y replaced by 0. Now you will have only 3z square you will get. Okay, you can see here. Also, what is v sub x? V sub x. In the previous slide you can see. So here also you can have 3z square because second term and third term becomes 0 since y is 0. This term and this term becomes 0. So you will have 3z square plus 4 only. Okay, 3z square plus 4 only. 3z square plus 4 dz plus arbitrary complex constant c. Now you will have, here you can see, here we have 3z cube by 3 plus I times 3 z cube by 3 plus 4 times z plus c. You will have z cube plus I times z cube plus 4z plus c. I can write it as 1 plus I times z cube plus 4i z plus c. This is our capital F of z. Okay. We calculated capital F of z. Now my interest is not with not capital F of z. I want small f of z. Okay. Now I have the formula from, you can see, from equation 4. From equation 4, I can write small f of z as capital F of z by 1 plus I. Okay. So this implies small f of z is 1 by 1 plus I times, here 1 plus I times z cube plus 4iz plus c. Okay. Now I am simplifying this. You will have only z cube first, then 4 times I by 1 plus I times z plus c by 1 plus I. Okay, c by 1 plus a. Since in this term we have arbitrary constant c, I can write simply big C. Okay, I can have z cube plus In the second term, I am taking conjugate of the denominator. It is 4i 1 minus I by 2. Okay, here you can multiply with the denominator, multiply with 1 minus I, you can get 2, and z here, and this one I am writing as capital C, because C is a arbitrary constant, capital C. So here you can get, I'll write once again this term. This is Z cube. Next, it is here we have 2 times. Okay, next you will have 2i square. 2i square is minus 1. So it is 2z. Next you will have plus 2iz. 2iz. Okay, plus c. This is the required solution. This is the required solution. For this function, sum of real and imaginary part will be this one. So this one we calculated with the help of Milne-Thomson method. Okay, I will discuss one more problem. Okay, see this one. Here it is given that difference of real and imaginary part. Okay, now I will take let f of z, whose real part is u and imaginary part is v. Okay, then I times f of z will be I times u minus v. So this is 1, 2, adding 1 and 2. We have 1 plus I times small f of z, which is u minus v plus I times u plus v. I am writing the same expression as capital F of z is equals to capital U plus I times v. Okay, this is important, where this is equation number 3, and I am writing where what is capital F of z? Capital F of z is the constant multiple 1 plus I times f of z, which is analytic, and I am giving it is equation number 4. And I know I'm defining capital U as u minus v and capital V as u plus v. Here, what is given to us? U minus v is given. That means what is given? Capital U. Capital U is given, which is capital U, which is a function of x comma y, and it is given that u minus v. Okay, so u minus v is cosine x cos hyperbolic y plus sin x sin hyperbolic y. Now I know capital F of z, and I also know its capital F of z, and I also know its real part. Real part is already there. Okay, so now what I will do, I am going to calculate capital U sub x. It's a partial derivative with respect to x. So this is useful for me in Milne-Thomson formula. So partial derivative with respect to x is, so minus sin x, it is cosine hyperbolic y plus cos x, here sin hyperbolic y. This is in terms of x comma y, and I am writing u sub y in terms of xy. So I have to do partial derivative of capital U with respect to y. So I will have cosine x and cosine hyperbolic function is sine hyperbolic function, plus here I have sin x cos hyperbolic y. So I calculated u sub x. I also calculated u sub y. Okay. Now I am going to apply Milne-Thomson method. By Milne-Thomson method, we have, so I am constructing capital F of z. Okay, because I know capital F of z. See here, capital F of z analytic, and also I know the real part of capital F of z. Okay, that's why I want to know what is capital F of z. I can, with the help of Milne-Thomson method, I can calculate capital F of z. See here, capital F of z. Here it is the integral of capital U sub x. Okay, in the partial derivative of capital U sub x, x replaced by z, y replaced by 0, dz minus, for here minus I times integral capital U sub y, x replaced by z and y replaced by 0, dz plus c. So here we already calculated this term, that simply replace x by z and y by 0. Okay, so if you do like this, you can have only minus sin z. Here you can get only minus sin z, dz minus imaginary number I and u sub y. Here you can see u sub y is here, x replaced by z, y replaced by 0. Okay, this term will be 0 because sin hyperbolic 0 is 0 and cos hyperbolic 0 is 1. Cos hyperbolic 0 is 1, sin hyperbolic 0 is 0. Okay, now you will have only sin z. Okay, here also you can get sin z. Integral sin z dz plus c. So you will have minus integral sin z dz minus I integral sin z dz plus c. Here you will have minus cosine z integration and minus I minus cosine z plus this is the constant c. Here you can observe that you will get cos z plus I times cos z plus c. Its value is simply 1 plus I times cosine z plus c. This is your capital F of z. Now from equation C, we have equation 4. From equation 4, in equation 4, I can write from equation 4, I can write small f of z as capital F of z upon 1 plus I. This implies I can easily calculate small f of z. Here it is 1 plus I times cosine z upon 1 plus I plus C by 1 plus I, because C is arbitrary constant. That's why we can write cos z plus capital C, which is small f of z. Okay, this is a required analytic function whose difference of real and imaginary part is this function. So with the help of these cases, case 3 and case 4, we can calculate f of z. Okay, similarly, you can do this problem also. If the difference is given and you have to find f of z, you can use which case? See, you can use difference is given this time. With the help of case 3, you can find the solution for the third problem. Okay, so summary of this lecture is, we have discussed this problem. Here, some of the real and imaginary part is given, and we are calculating f of z in this problem, first problem. In the second problem, it is given that difference of real and imaginary part is given, and we calculated f of z with the help of Milne-Thomson method. So similarly, with the same procedure, we also evaluate u minus v. Okay, so this is today's class, and these are the references I used it for this class, for this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.